Welcome to the video where we will address a common problem faced by newbies working with STM32 microcontrollers. The issue at hand revolves around a timer interrupt setup where, despite activating the interrupt with __enable_IRQ, the code inside the main loop does not seem to execute. It appears that the __enable_IRQ function causes the program to get stuck in an infinite loop, preventing it from moving forward. This leads to the main code not running as expected, leaving the user puzzled about the root cause of the problem. The solution to this problem lies in understanding the timing and execution flow of your interrupt setup. With the timer 2 TM2 configuration you've implemented, where the prescaler PSC is set to 1 and the auto reload register ARR is set to 8, an interrupt occurs every 18 machine cycles. However, the entry and exit of the interrupt routine itself take a minimum of 24 cycles. This means that the ISR is executing continuously without allowing other parts of the code to run. Hence, the main loop, in this scenario, is not able to proceed as expected, resulting in the observed behavior. In summary, the key issue causing the main code not to run as intended in this STM32 setup is the high frequency of the interrupt compared to the execution time of the ISR. The continuous execution of the interrupt routine hinders the progress of the main code, leading to the observed behavior. To address this, adjusting the interrupt rate or optimizing the ISR to reduce execution time can help ensure smoother operation of the program. We hope this explanation clarifies the situation for you and helps in resolving similar problems you may encounter in your STM32 projects. Remember, when working with interrupts, balance is key. Thanks for watching, and remember to like, subscribe, and leave a comment below with your thoughts. Happy coding!